video lecture on memory management. The topic that we will look at today is virtual memory, demand paging, and page replacement. What is virtual memory? Virtual memory is a technique that allows execution of programs not completely in the main memory. It uses secondary storage as an extension of RAM. It gives you the illusion of a large memory space. So let us empathize. The goal is to understand the needs of users and system constraints. In this context, programs are becoming larger than physical memory. Multiple processes compete for the limited RAM memory. We need to reduce waiting time and improve performance. So we need to understand problems like memory shortage, low execution, frequent disk access. So the outcome should be a system that allows large programs to run efficiently with the limited memory. Let's define the problem. How can the system run programs larger than physical memory? How can memory be used efficiently? How can page faults be minimized? So the outcome is we need for virtual memory with efficient page management. Let us ideate. So the possible ideas may be to load entire program into memory, to use paging to divide memory, to load only the required pages, and to replace unused pages when memory is full. There are solutions like demand paging, where we will load pages only when needed, and page replacement algorithms, like we have first in, first out, latest resource used, and optimal technique. So here the concept of virtual memory with demand paging and replacement strategies will be the outcome. And the concept of virtual memory. Logical memory can be larger than physical memory. Only required pages are loaded into RAM. So it improves memory utilization. It supports multi-programming. Demand paging is a technique where the pages are loaded only when needed. If a required page is not in the memory, a page fault occurs. Operating system loads the page from the disk. A page fault occurs when CPU requests a page. Page is not present in the main memory. So the result is the operating system must load the required page from the secondary storage. So how to handle the page fault. CPU requests a page if not in the memory, a page fault occurs. Operating system checks the page location on the disk. Page loaded into a free frame. Page table should be updated and the instruction should be restarted. Let us discuss the advantages of demand paging. The advantages are reduced memory usage, faster program startup, efficient use of RAM. It supports large programs. Page replacement. It occurs when no free frame is available. Operating system must choose a page to remove in that scenario, and new page loaded into the free frame. So the goals of page replacement are to minimize the number of page faults, to improve system performance, and to use memory efficiently. Common page replacement algorithms. First in, first out, least recently used, and optimal page replacement, and clock algorithm. First in, first out algorithm replaces the oldest page in memory. It is simple to implement, and it may suffer from Pallady's anomaly. Latest resource utilized. So here we call the algorithm least recently used algorithm, which replaces the least recently used resource, the page. And then it gives a better performance than FIFO algorithm. It requires tracking of page usage. Optimal algorithm, it replaces the page which is not used for the longest future time, and it produces minimum page faults. It is used mainly for comparison and analysis. Thrashing. Thrashing occurs when system spends more time swapping pages than executing. The causes are high multiprogramming, insufficient frames. The solution is to work on the model setup and limit the page fault frequency. So these are the comparison of the various algorithms discussed. The algorithm FIFO is simple. It is moderate in performance. And yes, we can use it practically. And the optimal algorithm, it is complex and it is best to performance and it has no practical usage. And the least recently used algorithm is moderate and it is good in its performance and it has its practical usage. The disadvantages are the page fault overhead and then thrashing possibility and increased disk access. Let's summarize. Virtual memory provides abstraction of large memory. Demand paging loads pages when needed. Page replacement optimizes memory usage. And the proper algorithm selection improves the performance. That's all for today's class, and let's discuss another topic in an upcoming video. Thank you.